Okay, so when you multiply these numbers together, you're going to get an acceleration of negative, because it's slowing down, 8829 meters per second squared. All right, and so then you're going to go to VF squared is equal to VI squared plus 2A delta D. You're trying to find how far did it go before it stopped, so VF is 0. So rearranging for delta D, it'll be negative VI squared over 2A. So negative, and your VI was what you had gotten earlier, so 22.47 meters per, I think it was 475 meters per second squared over, don't lose your negative, over 2 times negative 0.8829, etc. meters per second squared. So the negatives are going to cancel out, and you should get 286.06 meters. Okay, so that's it for number 3. Next up, number 11. Number 11 is a ramp in a gym and Throckmorton. All right, so it says, your phys ed class sets up a ramp in a gym. The ramp is 4 meters high. One day when Throckmorton is standing at the base of the ramp, a classmate decides to go bowling and lets a 30-kilogram medicine ball. Okay, and Throckmorton is standing down here. So the ball's going to roll down and smuck Throckmorton. So this is part 1, which will be energy. It's going to smuck into Throckmorton, who is then going to stick to the ball, and then he and the ball are going to slide across the floor, and I think it says for 2 meters, and it wants to know what mu is. So part 2 will be momentum, and then part 3 will be energy again. Okay, so first energy. So 1/2 mv initial squared, mg h initial, 1/2 kx initial squared equals 1/2 mv final squared, mg h final, 1/2 kx final squared plus E lost. So the ball's rolling at first, and usually when it's rolling on just a level, normal surface, there's not going to be any friction. Over here it's sliding because Throckmorton's stuck to him, and that's different. There will be friction. There's no spring. At the top, no speed. At the bottom, no height. So you have mghi equals 1/2, I canceled out the wrong one, 1/2 mvf squared. The m's are going to go, you're solving for vf. So vf squared will equal to 2ghi. So 2 times 9.81 meters per second squared times 4 meters. Take the square root, and you should get 8.85889 meters per second. And this becomes the speed with which the ball goes into the collision. So momentum. So m1v1 initial, m2v2 initial equals m1 plus m2v final. I think my pen's dying. Throckmorton isn't moving initially, and we're looking for the final. So v final equals m1v1 initial over m1 plus m2. Medicine ball was 30 kilograms, 8.85889 meters per second, and the two 50 and 30, they're 80 kilograms added together. So after they've stuck together, their speed is 3.3221 meters per second. And this becomes the speed which they go into the energy equation again. So 1/2 mv initial squared, mgh initial, 1/2 kx initial squared equals 1/2 mv final squared, mgh final, 1/2 kx final squared plus E lost. And this time, the only thing on the final side is the E lost, and on the initial side, kinetic. So 1/2 mv initial squared equals work done by friction. So the negative, because friction's going backward, delta D cos theta. So 1/2 mv initial squared equals negative mu mg, because it's on a flat surface, no cos theta, delta D, and this cos theta is going to be cos 180, and so the negatives will look after themselves, and we're looking for mu. So the m's are going to cancel. So we're going to have mu is equal to vi squared over 2g delta D, and the negatives are gone. The v is the 3.322 meters per second, and it's squared, over 2 times 9.81 meters per second squared. And delta D was 2 meters. Do the math, and you get a mu of 0.28125. Okay, so that's number 11. Next up, number 12, my frog. My pet frog, I believe. Carol, my pet frog. So while I'm studying Carol, no, I'm wrong, that's not number 12, I was just guessing. Number 12 is the spring. Okay, so I have a spring, and I should read the question. Maximum speed of a 3 kilogram box, so we're going to pull it out here. So this box is 3 kilograms, and the maximum speed, so maximum speed always happens here in the middle, and it's 1.12 meters per second, and here it's x is 0. Oscillating on the end of horizontal spring, amplitude of oscillation is 0.8. So 8 out here is 0.8, and that's x, and its speed out here is 0. Okay, and so the question wants to know what is the force constant. So energy again, 1/2 mv initial squared plus mg h initial plus 1/2 kx initial squared is equal to 1/2 mv final squared mg h final 1/2 kx final squared plus E lost, and there's never any E lost with the spring, so that's gone. Let's call this one our initial and this one our final. So initially no speed, no height, but it has an x. Finally it has a speed, no height, and no x. So we're left with 1/2 kx initial squared equals 1/2 mv final squared. The halves will cancel, and we're trying to get our k, so divide by x squared. So mv final squared over kx initial squared. And I'm going to run out of time before I finish this. So 3 kilograms times 1.12 meters per second squared divided by x was 0.8 meters squared. And so when you do this, you get